Cool, it's being recorded. Nice. Let's go to slide 1. All right, let's get started. Cool. So the idea of, James, can you go on mute? It's kind of like background noise. Thanks. Sick. So the idea of today's knowledge share is to go over the regulations that we follow as per FSGP, which is Formula Sun Grand Prix, and ASC, which is the American Solar Challenge, and possibly WSC, World Solar Challenge. We haven't been to that competition in a while, but it has slightly different sets of regulations. However, it's just really useful to know that all these regulations, all of them are completely fair, but they provide the necessities for the minimum product of our solar vehicle. We have to consider them because that will essentially let us attend competition, but there are also other factors to our design that we have to choose and that regs won't describe, because we have to spec our components, for example, to be most effective, and any communication is not really specified in regs. So that's the main usefulness to this meeting, or this knowledge share, especially also that we have taken this 80-page document and given you a high-level understanding of what it comes down to for these competitions. And in general, they're just awesome experiences. So it's fun to talk about, and it's also a good thing to look forward to attend. Okay, next slide. Cool, so our agenda, the regs are really broken down into 3 components, which is the regs breakdown, the technical breakdown, and operations. And we'll also talk about scrutineering, which is the main component that we have to make sure we are good to go for when we're there on competition day, or week, really. I've also linked the ASC regs on that page. So when this is uploaded, it's just the one that we were following for this document. Cool. So I'll go over section 1, the regs breakdown. So what is the purpose of all of this? At the end of the day, we're making a solar car for a variety of reasons, but the competition itself is a way to display our engineering creativity and to gain experience in an awesome learning environment, have some friendly competition, and also gain automotive industrial experience, because at the end of the day, we are driving in these cars. So things like meeting specifications for temperatures and meeting specifications for safety, those are very important, and we reflect that in our design. So this competition lets us showcase that. And then finally, we're a solar car team, and the innovation in our design is really put on display here because we're all driving EVs that harness energy from the sun, and our car particularly is meant to be kind of like a sedan and have 4 people, so that's kind of cool. And the regs just basically say that in other words. So the regs then go to talk about administration. I guess before, let me just give you a preview of how the event works. So FSGP is Formula Sun Grand Prix that happens every year, and it's a track-based competition. So every year we meet in a location that's determined beforehand, like a year before in advance, and is provided to all the teams that register. They also tell us both the location, and every other year we have the American Solar Challenge, which is another event that happens right after FSGP. This event is, we'll talk about it a lot more later, but it's basically a race across the states, which is pretty cool. And the last one was in 2018. The next one was supposed to be this summer, but it's being pushed to next summer. So during these events, there's a lot going on because we have all these teams, and then we have to have what the regs call are the administration, which are basically like a tent put up for headquarters. And there's various officials during the event. There's the regulations manager, making sure that, or keeping track of all the regulations that are being met, and also looking at penalties that need to be given in various situations. And then the event director, also like a management kind of position, chief inspector, in charge of the team that will be inspecting vehicles, timekeeper. This event is for us FSGP at least, which is the first part. It's a week-long event, and it consists of 3 days of scrutineering, which we'll talk about more later, but it's basically the equivalent of testing. And then two I think days, or actually maybe I got that switched. 2 days of scrutineering and 3 days of track race. Yeah, I think it's that. So where did I switch it again? Anyways, Liam will talk about this more. But in any case, though, that's kind of how the layout of the week goes. And so keeping time and schedule, that's also like a subdivision of administration. And then the people that apply the regulations are the way the regulations are applied to are for scrutineering, qualifiers, and the tour, which are like the 3 stages of the American Solar Challenge coupled with FSGP. So they're like the 3 stages. Yeah. Next slide. Right. And then the regs go into safety. And this safety is really not about specifically the entire vehicle, like electrical system safety as well as mechanical safety, but it talks about how, like at a high level, the equipment we need to carry in the car at all time for the people really that will be driving and be surrounding the car. So it's very, I also want to make it pretty clear that even though we may pass all of the scrutineering tests, and in many cases teams do, and go to competition and see really high level safety concerns. So so it's just always good to remember that we're liable for our vehicle and the failures it goes throughout the entire event. And we're not exactly good just because we passed the tests in scrutineering. We have to make sure we're constantly aware of our vehicle, and our design has to primarily be focused on safety. Because at the end of the day, we're putting ourselves in this, and that's a crazy amount of risk if you're not like focused around safety. So what does safe actually mean? It means it's a road worthiness ready car. That means we could actually drive it on the road in the setup that's used for ASC with its support vehicles, and it passes the minimum regs of competition. And of course, it maintains those minimum regs plus the regs we have put for other systems not outlined. So every competition, there will be a safety officer, and they have to be trained in first aid and CPR. Which includes CPR. And so we elect one during the terms for competition. So if you guys are interested in competition, which you should be, that's actually a role that someone has to take, and they can't be a driver or a team manager, but it's a very important role because there are a point of contact in case of a safety concern. And then we have a safety kit. So this has to be carried with us in our support vehicles during the entire competition. And it's especially important because there have been lots of instances where a car will break down and stop, and things like fires can happen. So that's why the safety kit kind of includes first aid kit, safety vests. Everyone has to be wearing that during competition when the car is moving and not just like stopped at the pit. PPE for battery handling when we have to, if there is a need to replace cells or modules, we need the equipment for that. We need orange cones with us at all times, warning flags, a fire extinguisher, that's very important, battery material safety data sheet, and then a battery spill kit, which is also sometimes just like 40 kilograms of sand and like a shovel or spade to apply to. And we need a method, or it could be another method of battery fire containment. And then we need a container for damaged cells. So that's like the bare minimum in the regs too. Now we have to show up with this equipment. And we don't need, I don't believe we need to carry this in the vehicle itself. Most of these things, I mean, people in the vehicle must have like the safety vests and the proper equipment, but yeah, this is for the supporting vehicles or at the pit during FSGP. Next slide. Cool. So then, so we hear about this competition and we get like the outline of how it's going to happen, or at least a rough outline a year in advance. And before we can just like, you know, show up to the competition in July, it's usually the beginning of July, there's a lot of paperwork and deadlines to be met. So the reason I want to bring this up is because we've actually talked to past leads that have had some like pretty sad outcomes because they worked really hard on their car and they like grinded until like the beginning of June or somewhere really close to competition, but they weren't allowed to participate because they actually missed their deadlines for some track fees and forms, which really sucks. So in addition, this is like, this is actually very important for us as well because we have to include a couple of documents that are technical in nature. So in the initial registration package, and we sent it because we were planning to go to ASC 2020 this summer, we had to send the preliminary vehicle data report in December and the vehicle data report in January. And these are both technical documents. And so the PVDR, it has preliminary information about the electrical systems, the batteries, the solar cells, the mechanical structure, as well as battery protection, I think. So that all had to be sent, and we have to come up with the data and have the appropriate approval forms and send out then. And then there's another package, the track registration package, which had the VDR, which also the hardware leads we worked towards getting, which needed a solar cell or a solar report, a battery report, protection report, electrical report, and a bunch of mechanical reports as well. So other things we have to send are team photos, our number, which we have reserved as 24. That's our team number for I think the like past 30 years. And then our team data sheet, which is like a high level outline of our car, like of the important characteristics that make up our car, like the battery weight and capacity, the chassis description, braking architecture, and wheel specs, and the list of all the leads or DRIs. Continue. And then we have so this is a technical, there is a section just dedicated to how the technical documentation has to be laid out. So our PVDR has the following characteristics, and if you guys want, I could also send you what it looks like. It's this document, like when we send it to the people, we're sending them to the scrutineers, who are the people who are going to be testing our car. And so they will give us feedback whilst we're sending it to tell us if we have strong architectural flaws. Like for example, we sent them our battery report and they suggested to add more, I think, thermal taps, because for the number of cells we had, it would be better to have more measurements for the thermistor data. And so we edited that, and that like helps us make sure, or that gives us a point of contact to make sure that we aren't making architecture with fundamental flaws. So the PVDR includes rollover and driver impact protection, the overview of the electrical report, which is mainly the electrical diagram, the preliminary battery approval document, battery specs and testing, and the timeline for the testing, as well as a solar cell approval form. And then there also needs to be an engineering build review, which is mainly for mechanical, but they have to, before they can submit any of their documents, they have to review with an experienced engineer their design. And so I think when we were sending out these documents, the send out kind of got delayed because of feedback on that. So yeah, it's just another really important part in our year of design. And then we have the VDR, which is the actual like solid documentation we have to provide, and which will be what is heavily reviewed. And if you can see in the bottom left picture, you on ASC's website during this like stage, and I'm not sure if they like took it down, but you could see how all the teams are doing in terms of like these passing goals, and finishing all of these as green in like first and as a priority is good for competition, because it'll like let us go through scrutineering first. And every team wants to do that because then you get a time advantage when you're starting the race. So the VDR has the mech tech report, the electrical systems tech report, battery protection tech report, and solar cell tech report. We basically did most of this during the winter break. Yeah. So we can skip over, I guess, the outlines of them. But yeah, as you can see, they have like certain requirements. And I can actually just upload the documents to Confluence. So that'd be cool. Okay, next slide. Yeah, so the event components ASC. So remember how I was talking about the 3 stages before? There's scrutineering, qualifiers, and the tour. Scrutineering, we need to get all green status before we can move on to qualifiers, or at least blue status. Green means that it's approved and we're ready to go. Blue, we can talk about more later, but it means that we're good to go, but we have penalties because some things are kind of out of spec. And so that will affect us in our scoring during qualifiers, as well as their position. But in any case, so scrutineering, a set of tests during the first 3 days, and the priority goes to teams to finish the scrutineering for who finished their initial package registration forms and all the administrative information first. So also another thing about scrutineering is a lot of the tests, there's the electrical component to scrutineering, and Liam will go into this a lot more later, but there's also a mechanical portion, and one part of the mechanical portion is the dynamics testing, which requires us to do like tests like slalom tests, and so we have to repeat the tests for every driver. So it is quite a big process, and we have to make sure our car is ready to go when we get there so we can just start testing. And then we have qualifiers, which is the main component of FSGP, like the track race. So we need to have at least all the greens or at least blues from scrutineering to be able to go to qualifiers. And we have to pass qualifiers to be allowed to participate in the tour, which is the last step, which is for ASC, the cross-country event. And if we have at least all green or all blues, we will probably be able to be allowed, depending on the circumstances of the penalties. And then that will like deduct from our scoring during the tour, which is not good. But we can only go to the tour if we pass a certain kilometer limit or kilometer minimum in the qualifiers in terms of laps we take. So it's very important that we like try to pass with green as well, because like for example, our 2018 ASC competition, MS12 had issues with braking because of the center of gravity of the car. So we had a blue pass on that, and that was not good for the tour, because it was kind of a blue pass, but they weren't too happy about it, so they weren't going to let us participate, but they did eventually. But we took heavy penalties for it, so our scoring was pretty not good. Yeah, but those are the 3 main stages. And then our vehicle classes are another part of this competition. You'll notice that most of the vehicles are still single occupant vehicles, SOVs, and that means they have more of the spaceship car design, or they're also called Challenger class in a World Solar Challenge. And they're the traditional competition that started 30 years ago, because they're really lightweight vehicles meant for only one person to sit in, and they race much faster than our class, which is the multi-occupant vehicle. It's meant for multiple occupants, as in the name, and it's also called the cruiser class of vehicle. But there aren't as many teams into MOVs right now, but it's like growing for sure. Like this competition, we were supposed to have a couple more than in FSGP 2019, which is really cool, because at the end of the day, the innovation really comes from how we can put this design work into something that would be useful for like a consumer level. And then during competition, there's also a class called grandfathered, which just means the car competed in a previous competition. So it can't really compete for it can't compete for like rankings, but it can compete just for like demonstration and just like being involved in the competition. Yeah. And cool. So now Liam will go over the technical breakdown of the report, which is a pretty large portion. So it's pretty high level the way we've kind of outlined it. But we will try to cover as much as possible.
Yeah, and I'll focus more on like the electrical side of things because this is the harder team. But yeah, as for the solar collector, you're allowed, I guess, like 3 different categories of solar cells. We use silicon solar cells. Gallium arsenide are much more expensive, but they're more efficient. So, like, ideally, if we could afford gallium arsenide, we would use those, but we don't. So, and then each vehicle, depending on the type of the array that you have, will have a limited size of array space that you're allowed to use. And this tries to equalize it between different array technologies. So teams that have gallium arsenide cells would be allowed to have like smaller arrays than silicon. So for silicon, the limit is 5 square meters. Some teams, I think, in the past have had concentrators or other things that will collect sunlight from a larger area and concentrate it onto a smaller area of cells. So the area limitation that I mentioned just now, it would apply to like the total area that the concentrator takes up, not just the array size. You're only allowed to have a maximum of 6 different types of cells, so that would be different cell chemistries as well as also different cell sizes. During scrutineering, you have to provide samples of your cells so that they actually know they can test them and actually see which cells you're actually using. So all your array has to be standalone as well. So a lot of teams, when they're charging, they'll tilt their array towards the sun to be more efficient. But that whatever structure is tilting it has to support its own weight. It can't be held up by people or parts of anything that's not part of the car.
Yeah, usually during competition, like during the evening or after all the like testing has been done, people will just take out their array and let it like face the sun for the rest of the day, just to collect that charge.
Mm-hmm. The array also gets very dusty, which ruins the efficiency. So you're allowed to spray it with water to clean it. And then there's fairly strict regulations about, I guess, what can be around your array. So if you do tilt it towards the sun, and then like you're not allowed to put anything on the ground that might reflect more light into it. So you like don't put a white blanket on the ground or anything like that. SOVs have an energy storage weight limit. So there's a table there showing, depending on your battery chemistry, what your weight limit is, but that doesn't apply to MOVs. You can have a supplemental battery as well that powers some like things like driver fans, the horn. You can power I think you can power your battery protection system in the event of a fault, and a few other things as well. And then you're also allowed to have like an aux battery that like it's basically the same thing as supplemental. We basically have an aux battery that will power the critical systems before the main battery is connected. So the protection circuitry that you're required to have, you need to have active protection if you're using like lithium, like a rechargeable lithium ion based battery cell. And this just means that when the battery cells approach unsafe conditions, that it will automatically disconnect the battery pack. And then we have passive protection for our auxiliary battery. And this just means that the state of charge, I guess, will be just like given to the driver, and the driver can decide when to disconnect it or stop using it. Other than that, there's other regulations about the battery enclosure. So it has to be isolated with at least 1 megohm of resistance between the I guess the rest of the car, like the chassis and everything. You also have to have marking on it to signify that there's high voltages there, and it has to be like, I think it's at least 10mm font, so that people can see it from far enough away. You have to have ventilation to keep it cool, and that ventilation has to come, so the ventilation can either come from outside the car or in the main cabin, but then it has to exhaust outside the car. So you can't have it recirculating to like the passenger cabin or anything like that. And then you also have to provide methods of securing the battery pack so that you can't like interfere with it during the race. You can't change out modules or cells or recharge it without them knowing.
Also, just to like stress the importance of isolation, like a really easy way to take out the mech team is to not have isolation with their chassis body, and that would be very bad. So again, that's like very important for our safety. And also this entire section is basically the electrical technical section of the regulations. So yeah, we're basically in charge of making sure the power requirements are met.
So your main battery pack also has to be fused. It has to be rated for less than 200% of your max current that you expect to draw, or and it also has to be less than 75% of your wire capacity so that you don't risk melting your wires. It has to be high, like a fast acting fuse, that as soon as you have like a short circuit or some other overcurrent condition, that it disconnects very quickly. Anything else that also connects to the batteries needs to be fused or current limited. So this would include like voltage taps for measuring the voltage of each cell. Yeah, your cables just have to be appropriately sized for the system currents that you would expect. The regulations are fairly vague about this, but basically a scrutineering, you have to like convince them that you've properly sized your cables and have sufficient safety factors there. You have to have a main power switch that's responsible for disconnecting the battery in the event of a fault. We have two relays on the high and low sides of the battery that it has to isolate all high voltage coming outside the box. It has to be rated for proper voltages, like the proper DC voltages. The driver has to be able to control it as well. And then the BPS system has to also automatically trigger it if there's a fault condition. In the event of a fault, there's an indicator on top of the car that has to blink to signify that there's a fault. And there's also an indicator on the dashboard that indicates to the driver that there's a fault. In addition to like any regular faults that you could have, like over voltage, any current faults, temperature faults, you also have to have a kill switch that will trigger a BPS fault. And so there's two of these. One of them is on the outside of the car, so that anyone, like if the car crashes, someone outside the car can hit the switch and cut off power. And then there's also a large red one inside the car that the driver or occupants of the vehicle can press. Basically, there has to be one driver who's in control of everything. No one else can have control over like the vehicle while it's being driven. The accelerator pedal has to return to like the 0 position when it's not being pressed, and it basically has to be positioned how you would find it in a regular vehicle, so to the left of the brake pedal. And then for cruise control, teams are allowed to have it. I don't know how common it is, but teams are allowed to have cruise control, but it has to automatically deactivate when you brake.
Also, the driver can only activate it. Yeah, we can't have telemetry controlling or someone else externally controlling the speed of the car.
So anything greater than 32 volts is considered high voltage, and it has to be protected, basically like concealed so that you can't accidentally touch it. It also has to be labeled. you have to be careful because the carbon fiber that makes up the body is also conductive. So we have to make sure that it's isolated from anything that's high voltage. And then there's a lot of covers just to ensure that you can't accidentally touch any of the boards. We are required to have a J1772 compliant vehicle charger. So this will essentially convert 120 or 240 volts AC to a DC voltage that we can charge our battery pack with. It basically has to be secured and sealed and isolated from it has to be like waterproof and everything, so there won't be any accidental shorts or connections. And then so all the AC and all the high voltage AC, high voltage DC has to be isolated from each other, and also the low voltage systems. There's a whole communication protocol that goes